All right, Algebra 1, we are back. And wow, we're in Chapter 8 already. How about that? Chapter 8. And the first section is going to be adding and subtracting polynomials. And that's what we're going to do. We're going to write polynomials in standard form, show you how to do that, and then we're going to show you how to add and subtract them. First, some terminology. It's math class, just like any foreign language, Spanish, French, whatever, you speak those languages. So in math, let's speak the math language. So polynomial is a monomial or sum of monomials. So we learned last chapter what a monomial was, and now so we either have a sum of those, or them by itself would be a polynomial. Binomial is a sum of two monomials, and then a trinomial. Think about it in terms of bicycles, bicycle, tricycle. Trinomial would be a sum of three monomials. So when we think about that, polynomial just means many, two or more. Okay, or it could be a single monomial as well, but generally, because you could have more monomials than just two or three. And then this one would be, so poly means many here. The prefix bi here would mean two for binomial, and tri, we know that means three. Okay, and then the other thing is to think about the word sum. Okay, sum could be plus or minus. Okay, because minus, subtraction is just adding a negative. So when we talk about sum, yes, sum means adding, but subtracting is just adding a negative. So we can say that that's a polynomial as well, too. The negative actually works as a sum. Okay, so let's go down here and decide, is it a polynomial? Yes, and then I say what it is or no, okay, and which one it is. All right, so the first one, 6 minus 4. Well, this is just a simple yes. It's just two terms. There's a subtraction in there, and it's two terms, so it's a binomial. All right, you got a one term here, you got your second term here. There you go, two monomials makes a binomial. All right, B. B, remember we talked about you can't have variables in the denominator. So because of this D right here, we can't do it, so it's no. Because you've got a variable in the denominator, and that's no good. Okay? All right, letter C. Well, we have a monomial here at x squared. We've got a product here. That's good. It's another monomial. And we've got another one here at -7. So we got three different monomials. So that's yes. We're just adding and subtracting in between them. And because there's three of them, we call that a trinomial. All right, let's go down to letter D. Letter D is just 26b to the fifth. So we've got a product. So that's yes, because you can multiply here. And it's just a simple monomial. It's just one term. There's no addition or subtraction symbols in between them. This one here is just the letter Y. So that would also be a yes, and that's just a monomial because it's just one term. And the last one here, we've also got another yes. We've got a -5b to the fifth. That's a product with an exponent. That's good. It's one monomial. You got another monomial here at -6. So you got two of them. So that's a yes. Two of them means it's a binomial. Okay? So just simple things with the terminology there. Okay, let's talk about the degree of a monomial. So more terminology, more things we have to think about. So the degree of a monomial is the sum of all exponents of the variable of a monomial. The sum of all exponents on the variables of the monomial. So you're going to look at all the variables and all of their exponents and add those up to get your degree. So let's say we had an example of 3x to the third y. Okay? Well, if we look at our exponents, we've got the 3 here on top of the x. And remember, this y actually has a 1 there. And we don't have to write it. But if we're looking at the degree, we're looking, there's a 3 as an exponent for 4. It's the sum of the exponents. So it's 3 plus 1 equals 4 for the degree. So as for the degree, you're just adding up the exponents. All right, so the degree of a polynomial, so that's just of one term, of one monomial. But of a polynomial, we're looking at it as being the largest degree of any one monomial. And in this case, so you're actually going to pick, the largest degree. And I'll give you an example of that. Okay. And so, for example, if we said that we had, say, 3x, use that 3x cubed y plus 4x squared y. Okay. So in this case, we're looking at a polynomial. We got two different monomials here. So we look at the degrees, and this degree would be 3 plus 1 for this one, because you got a 3 and you got a 1 here. And over here you got a 2 plus 1. So this degree would be 3 for this piece, right? So which degree has the largest? This first one has a degree of 4. So that's what we would say the degree would be. Okay? And polynomials are named based on their degree. So we would say this is a 4-degree polynomial. So in this case, with monomials, you just add them up. With polynomials, to find the degree, you got to add them all up, and then you choose the one that's the largest. In this case, this one here had a degree of 4. This one here had a degree of 3. So the whole polynomial would have a degree of 4. All right, next up. This little chart might help us a little bit. So is it a polynomial? What's the degree? And then is it a monomial, binomial, or trinomial? So let's fire through this one. This is yes. We know it's a polynomial. It has a degree of 4 because you only have one exponent here, and that's 4. And that's just simply a monomial because there's no addition or subtraction in there. It's just one term, just one monomial. All right, how about this one? Okay, be careful with this one right away because you're going to jump to conclusions and say, yep, that's a monomial. However, because of this -2, because of the -2 there, you're actually going to bring that down to the bottom, right? So you're going to have -7b times 9, actually, over a squared. So now you've got a variable in the bottom, in the denominator, which you can't have. So altogether, this is no, not a polynomial, which means it doesn't have a degree, and we don't have to answer those. This next one, there's no negative exponents, so we're in good shape here. So yes, this would be a yes. And now we're looking at the degree. We've got 2 plus 2 here is 4. Over here, we've just got a 2 for a degree. So 4 would be the degree of this one, because you take the largest one. And it's a binomial because you've got one addition sign in here, 2 terms. So it would be a binomial. All right, and the last one. Yes, we're dealing with a polynomial. And what type? We've got 1, 2, 3 different terms with subtraction signs in there. So it would be a trinomial. And then let's just talk about the order. Okay, this order of this one here would have an order of 2 because it's the exponent. Over here you'd have an order of 1. And over here, there is no order if there's no exponent, so it'd be 0. So 2 is our largest order, our largest degree. So we would call it, I have a degree of 2. I don't know why as I say in order, it should be degree. Okay? All right. Next up, let's talk about standard form of polynomial. That way we can actually get into the objective of adding and subtracting them. Okay, a lot of stuff here to cover in this one. So the first thing we want to do, standard form, is when you arrange it in terms from largest to smallest degree. And we used to call this descending order because you take it the smallest degree and work backwards to the lower one. And we talk about the term leading coefficient. What does that mean? Leading coefficient is the coefficient of the term with the largest degree. Coefficient with the term with the largest degree. So if we take a look just at this example down here, we've got it in descending order that's already in standard form. Where we can say, okay, this is the greatest degree is 3, so that's why it's leading the way. And then you can see that you've got your 3, your 2, your 1, and there's no exponent here. Constant would go last. And then your leading coefficient is what we talked about being 4. It's the lead coefficient. It's the coefficient in front of the greatest degree variable. So that would be 4 there. Okay, so let's do an example or two of this, writing it in standard form. So this first one. Okay, so the first thing we got to do is we just got to look at which one has the highest degree. Well, this one has a degree of 3. This one only has a degree of 1, and this one has a degree of 0. So we've got to reorder it and write it with this one first because it's the largest, 14x cubed. Then we'll go to the next one, descending order. So plus 2x, because there is no x squared there. And then we'll go with plus 16. And that would be your standard form there. Okay, and what is the lead coefficient? We'll call it LC. Would be 14, lead coefficient. Okay, how about letter B here? Letter B, we've got, well, what do we have? We have an order of 1 here. This one has an order of 0. Over here, we've got an order of 2, right? And then we've got an order of 3, actually, here with that exponent. So we're going to actually have to go with this one first, the y cubed. Now, that negative sign stays with it, so it would be a negative y cubed. Then in descending order, we're going to use this second, the one with the degree of 2, and that's going to be plus 3y squared. And then when anyone with a degree of 1, yep, there's that 5y, so plus 5y. Remember, if there's nothing in front of it, it's a positive. Okay? And then finally, the negative 6 comes at the end. And so that would be your descending order standard form. And what would the lead coefficient here be? Well, this would be a negative 1 in here. Right? If there's nothing in front of it, it's a negative 1, so our lead coefficient would be negative 1. Okay? So now that we know how to write it in standard form, we can go ahead and solve a couple problems here, adding and subtracting them. So let's take a look at our process for adding and subtracting them. Number 1, distribute negative for subtracting. So if there's a negative sign in there and there's parentheses, you're going to have to distribute the negative 1 in there. Okay? That's going to help you to add and subtract. If you don't do that, it's going to mess the whole problem up. And we'll talk about that as we go. Combine like terms. Anything that has the same variable with the same degree or same exponent, you can combine by adding or subtracting. Cross out those terms after combining. It's just something I do to make sure, hey, I've already taken care of those terms. Then you know that you're done with that. Okay, and then finally, we want our answer in standard form. And remember, standard form is we've got the highest degree goes first. And we go in descending order. Okay? So let's do a couple examples of that. All right, so this first one here, let's take a look at it. We've got a 6n to the 4th minus 4 plus 9 minus 2n to the 4th. So because of this plus sign right here, I know we're going to add. So I don't really have to do anything on step 1 about distributing the negative for subtracting because it's an addition problem. So I can just kind of rewrite it, and I'm just going to drop the parentheses here and just rewrite 6n to the 4th minus 4 plus 9 minus 2n to the 4th. Okay? So my next step was to combine like terms. So do I see any terms that can be combined that have the same variable and the same exponent? Sure. We've got an n to the 4th here. I've also got an n to the 4th here. So I can combine those. And I have a 6n 4th and a negative 2n to the 4th, which would give me a positive 4n to the 4th. And then I just kind of cross those out so that I know that I'm done with them. Okay? Are there any other terms that are like that I can combine? Sure. We've got this negative 4 here and this positive 9 here. There's two constants. So I can combine those. Negative 4 plus 9 gives me a plus 5. And that would be my answer of adding that polynomial. Okay? Number 2 is very similar. I'm going to skip that one for now. We'll come back to it in class. And let's look at number 3. Okay, because number 3 gives us a subtraction problem here. So because of this subtraction sign here, that means we're going to have to use the distributive property. And really, you're just distributing a negative 1 through that second set of parentheses. So let's make sure we do that first. We're basically saying this is -1 times this stuff. So let's make sure we do that first. So I'm going to just kind of rewrite the first one, 11 plus 4n squared, because nothing happened there. And now I'm going to distribute, because if I don't do this, it's going to change everything. So -1 times 3 is a -3. And then a -1 times a -6n squared would be a positive 6n squared. Negative times a negative would make a positive. So now I'm back in the situation. I've distributed, and now I can look for like terms. Do I have anything with the same variable? I sure do. Same variable and same exponent, n squared and n squared. So I can take a look at those and add those up. And I'm kind of doing it in that order to get us like saying, okay, well, that's the highest degree anyways, so let's do that one first. So I've got a positive 4n and a positive 6n. That gives us a positive 10n squared. And then I also have two constants, 11 and a -3. So 11 minus 3 gives us a positive 8. So that would be our final answer here. And I cross them out, know that I've dealt with them, and we're good to go. Okay, number 4, another example, just a couple trinomials here, but you're subtracting, so just remember to use the distributive property here as well. So -1 in front of there, and you're good to go. Okay, we'll do that in class as well. Okay, let's mess with this one a little bit. All right, so in this one, we got measures of two sides of a triangle are given. They're given over here on the right, and if P is the perimeter, that's over there on the left, find the measure of the third side. So we can add these up because it's perimeter, and we've got our perimeter given to us. We've also got the two sides. So the first thing we're going to have to do is we're going to have to add these two sides over here. Okay, so that's the first thing. We got a 4x squared minus 3 plus 10x plus 7. Because that gives us these two sides. We don't know that side, but we can find that later. So let's just first look at this and say, is there anything now that we can combine? Because we're adding, so we don't have to worry about distributing because we're adding. So we're in good shape. Is there another 4x squared? No, there's not. Is there another 10x? No. So those are going to stay the same. But we do have like terms here with a -3 and a positive 7. So I'm going to write this with the highest degree. So 4x squared. That x squared gives us the highest degree. Plus 10x. Remember, I can't combine those. Those are not like terms because this one's an x squared, this one's an x. Now I can combine the two constants. We have -3 and 7 to give us a plus 4. All right, so that is that. These two monomials added up, or polynomials added up. So I've got these two sides. This side and this side together make 4x squared plus 10x plus 4. But I need this third side in order to get the perimeter, which is given to me here. So if I have two of the sides and I want to find the third side, what could I do? Because I have the perimeter, I have all three added up, and I have two of the sides. How do I find that third side? Well, I would have to subtract. So I'm going to have to subtract. And what am I subtracting? I'm taking the whole perimeter, 10x squared minus 5x plus 16, and I'm going to subtract this piece over here, okay, this whole piece, because those were the other two pieces. So I'm going to subtract 4x squared plus 10x plus 4, right? We'll subtract there. And because I'm subtracting, remember, I have to use the distributive property. So it's always good sometimes to say, you know what, I'm going to put this in parentheses to show that I'm going to subtract that whole entity. And remember, that just basically means there's a -1 in front of there. So as I go through this and rewrite, I'm going to have 10x squared minus 5x plus 16. And I'm rewriting because I'm distributing. -1 times 4x is a -4x squared. -1 times 10x is -10x. And -1 times 4 is a -4. So just change the sign of everything in there. And now I'm on to the combine like terms part. So I've got to look at coefficients with the same degree, any like terms. Well, I've got a 10x squared here and a -4x squared here. So together, Those would make a positive 6x squared, because 10 minus 4 is 6. And I'm done with those, so I can cross those out. Let's look for any other common terms. Okay, we've got this one here. Negative 5x and a negative 10x. So together, negative 5 plus a negative 10 is going to give me a negative 15x. And I'm done with those as well. And the last thing is I can combine this positive 16 and this negative 4 because they're two constants. They have the same degree. So 16 minus 4 gives me a plus 12. And I did that. I've taken care of all the terms. I've combined them all. And I have it in descending order. My degree of 2, 1, and 0 here. So I'm in good shape. That's my final answer. It's in descending order. Okay? So a little bit to that problem, but if you're adding and subtracting polynomials, you're in good shape. Just remember, the biggest thing is when subtracting, you have to distribute that negative 1 through. Okay? All right, last thing, we're at the end. Here's our lesson summary. What's the most important thing to remember when adding or subtracting polynomials? For me, it's what I just talked about with subtraction and using that distributive property to go to the negative 1. But for you, it might be combining like terms. It might be crossing them out, stuff like that. And then finally, here's your practice problem. Subtract these two. So again, it's subtraction. So use that distributive property on the second one. And that is about it. I know it's a long section today, but there's a lot to cover. And bring some questions, and we'll go over them for the next class day. Okay? Thanks so much. See ya.